Work on reproductive system. Okay, so first let's start with the male reproductive system. We need to know that the primary or one of the reproductive structures is supposed to be the scrotum. The scrotum is supposed to be a muscular sac that holds the testes outside the body. And the reason why the testes absolutely have to be located outside the body is because that's what's needed for good sperm production. The sperm have to be produced at about 2 to 4 degrees below core body temperature. There's also supposed to be a specific muscle called the cremaster muscle. And the cremaster muscle is supposed to control how close or how far away the testes are from the body. So when the cremaster muscle contracts, that will pull the testes closer to the body and that will help warm them up. So that would happen if the temperature of the testes is too low and we need to warm them up. But if the temperature of the testes is too warm, which is really not good for sperm production, then what would happen is that the cremaster muscle would relax, and that would allow the testes to move farther away from the body, and that would actually help cool them off. Okay, and then speaking of the testes, we need to know that inside the testes that there are supposed to be 3 different types of cells. There's seminiferous tubules, interstitial cells, and then sustenticular cells. So we need to know that the seminiferous tubules, those are there to produce sperm. Then the interstitial cells are there to produce testosterone. And then the sustenticular cells are there to just nourish the sperm. Right, so the process of making sperm in the testes is supposed to be called spermatogenesis. So spermatogenesis is the right, spermatogenesis is supposed to be the process of making sperm, and that's what occurs in the testes. So the sperm are made in the testes, but they don't stay there. After they're made in the testes, they migrate to the epididymis. And it's in the epididymis that the sperm will mature. And they're also going to get pieces of equipment. So inside the epididymis, the sperm get a head, a midpiece, and a tail. The head is going to contain the nucleus with, of course, the DNA. But also on the head, at the very tip, is what's called the acrosome. And so we need to know that the acrosome is going to contain enzymes. And so, right, the enzymes of the acrosome, those are there to help penetrate the female gamete. We can try to remember that the M in midpiece is supposed to be M for mitochondria. Okay, now and then after that, there's going to be the flagella. We need to know that the flagella is supposed to be a whip-like tail and is supposed to just whip back and forth to help the sperm move. So all that is happening in the epididymis. Okay. So then after that, the sperm are actually just going to stay there until it's time for ejaculation. And then from there, what will happen is that the sperm are then going to move through a series of ducts and tubes. So the very first tube that they're going to move through is the ductus deferens, also known as the vas deferens. Okay, so you can see that the vas deferens goes from the epididymis all the way up behind the bladder to the prostate gland. And this is also where we get the name of the term of a vasectomy from, because a vasectomy is supposed to be changing or altering the vas deferens to prevent the sperm from being able to leave the male body. Okay, then after the vas deferens, there's the ejaculatory duct. So the ejaculatory duct is just a very short tube that's going to carry the sperm from the vas deferens through the prostate. Then the next tube that they move through is the urethra. There's 3 different sections to the urethra. There's a prostatic urethra, a membranous urethra, and then a penile spongy urethra. You can see that the prostatic urethra is in green, the membranous urethra is in pink, and then the penile spongy urethra is in yellow. Okay, so that's the flow of sperm. We need to know that it starts in the testes. Then they move to the epididymis. And then they just stay in the epididymis. And then they go through the vas deferens, then the ejaculatory duct, and then the urethra. So it's really important to know the order and the flow of the sperm. Now let's look at the accessory structures. Excuse me. So the first one we need to know about is the seminal vesicle. The seminal vesicle is supposed to secrete fructose. And the purpose of fructose is that that's the energy source for sperm. Because we already said that the midpiece of sperm contains mitochondria. But the mitochondria, they really can't make anything, or yeah, they can't make energy until unless they have like a sugar. Okay. Right. And so the sugar that the mid piece of mitochondria are going to be able to, the sugar that they're able to break down is going to be fructose. Okay, then the next accessory structure is the prostate. Okay, so we need to know that for the prostate, the prostate gland is going to secrete coagulating and then decoagulating substances. Okay, so basically the purpose of the coagulating is because basically I keep losing my train of thought. For the coagulating, once the sperm are inside the female body, their goal is to find the egg. They're not going to be able to find the egg if they come back out. So the coagulating proteins are there to help the sperm like stick and stay inside the female body. And then the purpose of the decoagulating proteins is that for the decoagulating, I mean, at some point after the sperm have been inside the female body for a while, at some point they need to break free from each other and go start finding the egg. And so that's the purpose of the decoagulating proteins. Okay, then the last accessory gland is the bulbourethral gland. So for the bulbourethral gland, basically that's supposed to secrete a neutralizing alkaline area or alkaline secretion. Okay, so because since the sperm travel through the urethra, which I mean, obviously urine also travels through the urethra. So if urine has traveled through the urethra before sperm, then this means that the sperm could get damaged by any acidic urine residue. So the bulbourethral glands will secrete this neutralizing substance in a way to like flush out the male urethra and prevent the sperm from getting damaged. Okay, now let's take a look at testosterone. So for testosterone, definitely it will help with spermatogenesis and stimulating the production of sperm, but it has a lot of other functions too. So first of all, it helps with muscle development and bone growth. It helps with the development of secondary sex characteristics, such as the deepening of the voice, broadening of shoulders, growth of pubic hair and axillary hair, and then also maintaining libido, or in other words, the sex drive in both males and females. Females actually do make small amounts of testosterone, very small amount, but most of it is converted into estrogen. Okay, we also need to know about the job of FSH in men and women. FSH, follicle stimulating hormone, that comes from the anterior pituitary gland. And that's supposed to stimulate the testes to make sperm, so it stimulates spermatogenesis. And then LH from the anterior pituitary, that stimulates the testes to make testosterone. Okay. Now let's take a look at the female reproductive system. Actually, before we do that, let me bring up a few questions for male, and then we'll do female reproductive. You can try this first one.
For the first one, I would pick C.
No, the seminal vesicle doesn't transport.
Oh, that's right. D.
No, that's the urethra.
Oh
So
my
it's the prostate.
gosh. And That's
Y-
that's the one I was gonna pick.
Yep. So, right, it helps with the motility, like we said, the coagulating and decoagulating.
For this one, it's C.
Yes. Hmm. Okay, that's fine for, well, wait, I might be able to find one or two more. Okay, you can try this one.
Okay. B.
Sorry, did you say B as in boy or D as in dog?
Boy.
Mm-mm, it actually does do this.
D.
Yes, the thing is that it does stimulate growth of hair on the armpits, but not hair on the scalp like your head. It doesn't have anything to do with that.
B.
B as in boy or D as in dog?
Yeah. B as in boy.
Mm-mm.
Oh, it should have found correctly. A.
Mm-mm. That should be the epididymis. It should be D as in dog. The
Production of
testes is
sperm.
where the sperm are made, and
Yes,
then
ma'am.
testosterone is also made in the testes. They're
Yes.
made in the testes, but then they mature in the epididymis. So that would be A. And then this one is actually the bulbourethral gland, technically.
Yes, ma'am. Okay.
Okay. All right, now let's move on to female. Okay, so for the first female reproductive structure, we need to know about the uterus. So the uterus is supposed to be a muscular organ that receives the fertilized oocyte and provides an appropriate environment for the developing fetus. So implantation of the fertilized egg occurs in the endometrium of the uterus. And then the narrow tip of the uterus that connects to the vagina is the cervix. So this is the cervix down here. It's just the connection between the uterus and the vagina. We need to know that the uterus has 3 different layers to it. Right, there could be a question that just literally asks how many layers are there to the uterus. So you need to know 3. But we also need to know the function of 2 of them. The third one's not important. So the 3 main layers are supposed to be the endometrium, the myometrium, and the perimetrium. The endometrium, we can think of that as the inner. Yeah, endo means inner. There are two sublayers to the endometrium. There's a stratum functionale, and then a stratum basale. The stratum functionale is the layer that gets shed and torn down during menstruation. And then the stratum basale is supposed to be the layer that helps rebuild the stratum functionale. Okay. Okay, then for the myometrium, the prefix myo means muscular. So this is supposed to be the muscular layer of the uterus. This is the layer, the myometrium is the layer that's going to contract during childbirth. And it also helps with, well, it will also contract slightly during the menstrual cycle and cause menstrual cramps. Okay, now let's take a look at the fallopian tubes. Okay, so we need to know that for the fallopian tube, sometimes it's also known as the uterine tube or the oviduct. So that's going to be all in here. And we need to know that at the beginning of the fallopian tube, there is a structure called fimbriae. And so the fimbriae, those are these finger-like extensions that are going to help sweep the egg into the fallopian tube. Then we need to know that the journey down the whole fallopian tube takes about 7 days from the very beginning to the very end. It is about 7 days. But we need to know that the egg is actually not fertile for that long. It's not fertile for 7 days. It's only fertile for about 24 to 48 hours. So that means that the egg probably will only have barely made it to right around here before time's up and the egg is no longer fertile. So this means that the sperm can't just be like sitting here in the uterus waiting for the egg to come to them. Otherwise, by the time that the egg got to them, it would be way too late. The egg wouldn't be fertile at all. So this means that the sperm have to swim through the uterus, up the fallopian tube, and find the egg in the fallopian tube before time's up and it's no longer fertile. So that's really important to know. Okay, so we need to know that fertilization occurs in the fallopian tube. You can actually try and remember that the F in fertilization is F for fallopian tube. Okay, so we need to know that fertilization, what it is that the egg and the sperm meet and the DNA combine. Where it takes place is the fallopian tube, and when would be after ovulation, within 24 or 48 hours after ovulation. We need to know that this is totally different than implantation. Many people get confused between fertilization and implantation. Implantation, first of all, what it is the egg's already been fertilized. The fertilized egg plants itself into the wall of the uterus and starts to grow. Like if you think about like a seed that's just kind of drifting in the wind, and then it lands on some fertile soil, it starts to grow roots in the ground. In a similar way, the fertilized egg does the same thing. It drifts through the uterus, and then when it lands on the endometrium, it starts to kind of grow its own roots and starts to embed itself into the uterus. That's implantation. And then where? We definitely need to know endometrium of the uterus. And then the when would be after fertilization. Okay, now let's take a look at the ovaries. Okay, so we need to know that inside the ovaries, there are supposed to be ovarian follicles. And each of the ovarian follicles is supposed to contain an oocyte, or in other words, a female egg cell. So we have the anterior pituitary. And then when the anterior pituitary releases follicle stimulating hormone, the follicle stimulating hormone, that's going to go to the ovary, specifically to an ovarian follicle. And it's going to tell an ovarian follicle to make, oh, hold on, let me back up. The follicle stimulating hormone, the message that that sends to the ovary is grow, get bigger. And as the ovarian follicle grows and gets bigger, it's going to be making more estrogen. And then the estrogen is going to go to the uterus. And the estrogen's message to the uterus is also basically grow, get thicker. Because the egg is going to be released soon. and we need a nice place for the egg to be able to land. So it's the job of the uterus to get thicker and try and grow to prepare for the egg getting ready to implant. Okay, but also at the same time, the estrogen is going to go back to the anterior pituitary. And it's actually going to tell the anterior pituitary to release the LH. Okay, and so right, basically the more and more estrogen that's released, the more and more that's going to tell the anterior pituitary to release LH. Then the LH, when that's released, that's going to go to the ovary and tell the ovarian follicle to pop and release the egg. Okay, and then now let's take a look at, well, what happens after the LH is released and then there's ovulation. So let me draw this out again. So we have anterior pituitary. Let's see. Right, the anterior pituitary is going to release the luteinizing hormone, and then the luteinizing hormone goes to the ovarian follicle. Oh, oops, no, let me not draw it that way. That. The egg. So, right, the luteinizing hormone is going to tell the ovarian follicle to pop and get ready to release the egg. Or, well, to release the egg. Then after that, basically the egg is going to go, it leaves the ovary. It's gone. It's going down the fallopian tube, and it might get fertilized, it might not, and then it might implant, it might not, but fallopian tube. But it's totally left the ovary. It's gone. So but then we have left behind actually an ovarian follicle. Because you should think about like a balloon. If you pop a balloon, the air rushes out. It leaves. It's gone into the atmosphere, the room. But then you have left behind this deflated balloon part. Basically, the same thing happens with the ovarian follicle. The egg leaves. It's gone. But then you have left behind the ovarian follicle. This stays in the ovary. It never left the ovary. It's still in the ovary. And it turns into a gland called the corpus luteum. So we need to know that the corpus luteum that's actually going to be a gland that makes a really large amount of progesterone and then a small amount of estrogen. Both progesterone and estrogen are going to go to the uterus. So but they send different messages. The estrogen tells the uterus to keep getting thicker and to keep thickening the endometrial lining. Um, and then the progesterone, though, we need to know that the progesterone is actually going to say, don't tear anything down. It's going to say, yes, not only should you keep getting thicker, but you also shouldn't get rid of anything. So, because I mean, if the egg has implanted, we definitely don't want the uterine lining to shed. And then also, if the egg hasn't implanted yet, we don't want it to get torn down. We need to give the egg a little bit of time. Okay, but then at the same time, we need to know that the progesterone is also going to go to the anterior pituitary, and it actually is going to tell the anterior pituitary to stop releasing LH and FSH. The reason why this is because if LH was still being released, then that would cause ovulation again. And we don't want that to happen. We don't want ovulation to happen so soon after the first egg was just released. And we also don't want follicle stimulating hormone being released because the follicle stimulating hormone that would cause the growth of another egg. And again, the egg was just released. We just released one. We don't want another one being released so soon after the first one. So the progesterone is basically going to say, chill. Don't release anything yet. We just released an egg. Give the first egg some more time. Okay. Now let's take a look at this chart. This chart is supposed to help put everything all together again. Okay, so if we look at follicle stimulating hormone, when the follicle stimulating hormone is being released, that's going to the ovarian follicle. And its message to the ovarian follicle is grow and get bigger. And that's why you can see that as the follicle stimulating hormone is increasing, the follicle gets bigger. That's why. It's because the follicle stimulating hormone is telling the follicle to get bigger. In response, the follicle is going to be releasing lots of estrogen. And then the estrogen is going to go to two different places. First of all, the estrogen is going to go to the uterus and it's going to tell the uterus to get thicker. Tells the uterus to start to get thicker. Okay, then at the same time, the estrogen is also going to go to the anterior pituitary, and it tells it stop, stop. I'm sorry, no, it says more LH. Basically saying, I'm ready to be released. And then the more estrogen, the more LH. Okay, so that's step 3. Okay, then the LH, when more of the luteinizing hormone is released, that's going to go to the ovarian follicle and tell the ovarian follicle to pop and release the egg, especially when the luteinizing hormone reaches its peak, its maximum. Okay, and then now let's take a look after ovulation. So after ovulation, we need to know that this part of the ovarian follicle is going to turn into the gland. The corpus luteum is at step 5. Okay. Okay. The corpus luteum, we need to know that that is now going to make a huge amount of progesterone and then a little estrogen, but not that much. Okay, so now we need to know that the progesterone does 2 things. It goes to the uterus and it says, don't tear anything down. And then also the progesterone is going to tell the anterior pituitary to stop releasing the LH and the FSH. And then meanwhile, the estrogen, I should have done the estrogen in green there. The estrogen is basically going to tell the uterus to get thicker. And to keep thickening the endometrial lining. Right, now let's take a look at, well, what happens to the corpus luteum. So we need to know that the corpus luteum, the fate of the corpus luteum, depends on whether or not the egg is fertilized. So if the egg is not fertilized, then we need to know that the corpus luteum only lives 10 days. So from around day 14 till about day 24. Then after that, it actually is going to turn into scar tissue called corpus albicans. Okay, and so the corpus albicans, because it's scar tissue, it's not able to make hormones. And so because it's not able to make hormones, then the level of progesterone and estrogen are going to uh, decline. Okay, so this is actually what's going to cause some of the symptoms of PMS. And so basically the decline in progesterone and estrogen, that actually is going to make us feel really ugh and kind of lousy. Okay. And then right, we need to also know that high levels of progesterone tell the uterus to stay thick. So low levels of progesterone are basically going to tell the uterus to give up. And so that means that low levels of progesterone um, tell the uterus to give up and begin menstruation. Okay, and then the second option, right, is if the egg is fertilized. So if the egg is fertilized, the corpus luteum will continue to make progesterone until the placenta develops around the baby. Okay, so, right, and then the progesterone prepares the body for pregnancy. And then, right, basically the placenta will take over and make the progesterone. Okay, that should be it for female reproductive. Let's do a few questions on that. Actually, hold on. Let me go to the other set of questions. Okay, this is good.
C.
Yes. Mhm.
D. Oh, oh, okay.
Yes, we just need to know that ovulation is triggered by LH.